give you a brief overview of what we'll be discussing today. First of all, we're going to start with the introduction and background of the company where project took place. Then we'll go over the situation that we identified at the company that needed to be addressed and overcome, as well as the significance of the problem and to what extent this issue is affecting the company. Then we'll go over the objectives that we established to be attained, as well as the results that we expected from them. Then we'll talk about the process of gathering and collecting data that was relevant to our study. And consequently, that led us to developing solutions for the current problem. The presentation is going to be wrapped up with a conclusion, and we'll be open to any questions and comments that you might have. Having said that, I will hand it over to Zach, who will go over the background of the company.
Just a brief introduction to the company where this project is taking place. The company is Hydro Aluminum, located on the north side of Kalamazoo. They specialize in aluminum extrusion and fabrication processing, mostly for the automotive, fitness, sporting equipment industries. It is a pretty large facility at 140,000 square feet, and they are ISO 9001 and 14001 certified. So just a brief overview of the area of concern. This is a CAD model of the entire factory. Inside the yellow box is the shipping and receiving department, where the focus of this project will be. So what is the current problem within the shipping and receiving department at Hydro? Well, it's a pretty large department. The floor space is still very limited. They have a random pick and place process for all of the incoming finished goods. So any open space, whether it be on the floor, the shelf, anywhere really, they just place the part. This is resulting in a lot of clutter and disorganization on the floor, limiting the movement and travel on the floor space. At the same time, when shipping employees go to pick these products to bring them to the loading dock to be shipped out, it can be a very time-consuming process if you don't remember where the products were placed, who placed them, when they were placed. Also, this disorganization and the time-consuming processing is often resulting in late shipments, which results in penalties from companies or customer loss, which in turn results in profit loss. So some significances of this problem. First of all, since it's a lot of manual operations and it's a random process, there's an audit required to verify that the inventory in the shipping and receiving department matches the inventory in the SAP system. This audit is nearly $7,000 on a monthly basis, which translates into $70,000 throughout the year. It's this expensive because it requires 10 employees over 3 shifts each month. In addition, as I mentioned earlier, while the floor space is limited, there's tons of open shelves as a result of the disorganized pick-and-place process. Sometimes the shelves can't be gotten to because they're blocked by stock on the floor. This has resulted in a 65% shelf utilization, which is leaving many shelves open that could be used and open up floor space. Another issue with the stock on the floor is that it's often stacked very high because there's nowhere else to put products. This results in a safety issue, as some of the stacks are 10, 12, 15 feet high, and if these were to fall on a person or a fork truck, it could be a real issue. In addition, the stacking of finished goods and having to move materials to get into far corners where products may have been placed months or years ago can result in quality issues with corners being hit or products being crushed on the bottom of these stacks. So what is our objective based on all of these problems? Our main objective is to reduce the operating costs within the shipping and receiving department at Hydro. In order to do this, we want to optimize the procedures and processes done by the employees through standard operating procedures. We also want to increase the safety in the area by getting rid of a lot of the tall stacks and utilizing the shelf space that we have. And we want to obviously reduce the late deliveries as a result of the shipping and receiving department. While we can't control all late deliveries, as some come from production and supply chain issues, we'd like to minimize those that come from the shipping and receiving department. So now I'm going to hand over to Yaris to talk to you about the current layout within the department.
So for you to be able to understand how the shipment department operates, I will explain how the system runs. So as you can see here, this is the shipment department. The parts are received at the point of entry. Here's where the parts count is done and the materials are documented into the SAP system. This is done by manual data operating procedures. So once this information is entered into the system, the parts go to wrap and bundle where they are packaged for shipment. And from there, they are randomly distributing along the racks without a first in, first out, or FIFO priority of shipment. So when the shipment due dates arrive, they are sent to docks A and B for distribution of parts. So analyzing the current process at the shipment departments allowed us to identify problem areas to look into. And two of the main concerns that we looked at were, first of all, the manual data operating procedures. This has contributed to a lot of quality nonconformances because sometimes the wrong data is entered into the system, and sometimes this results in sending the wrong parts to a wrong customer, and this has become a main issue at the company. And second of all, the time spent to track parts along the storage area, because the locations are unknown because none of them have it designated as in a specified place where they can be located. So these were the two main problems that I wanted to look at. As you can see on the screen, this is a section of one of the racks. But what we're trying to convey on this graph is that these are unutilized. And not only the problem is that they're not being efficiently utilized, but also they are resulting in floor storage. The shipment department is in a constant state of disorder because the paths are blocked and is usually congested. And it has become a challenge to find space in the storage department because of the stacking parts on the floor. So as you can see here, we provided some calculations in order to identify to what level the racks were actually being utilized. And as you can see, only 65% of the racks are being actually occupied, which is a very low percentage because as you can see on the dimensions on the table, there is sufficient space that is provided, and that would suffice to store the parts that are being stored on the floor. Also, looking at the trends of the shipping delay, we can see that the trend is going upward, which has been dramatically increasing in 2012. And this has also resulted because of the constant disorganization at the shipment department and the lack of accuracy when it comes to data management of the inventory levels that they have. So we wanted to calculate how this problem is affecting the company in terms of cost. And we talked to one of the accountants at Hydro Aluminum to identify what was the holding cost that they were paying of the inventory that they were having. And 20% is what they pay on holding costs, which is given 15% of capital costs and 5% of storage, breakage, and spoilage. As you can see on the table, this is the cost of finished goods per pound in 2012, and about $1 million is being spent on holding costs, which is a considerable amount of money that could definitely be reduced. So in order to further analyze the system and to possibly come up with solutions for the current problems, we utilized a discrete event simulator problem model. And the three main aspects that we want to look at were the time that the parts stayed in the system, the utilization of the racks, and the productivity and throughput of the warehouse. So now I'll hand it over to Joe, and he'll go over the initial findings of the problem model simulation.
So as Yash was describing, we were able to collect 5 years of historical data from Hydro Aluminum's Enterprise Resource Planning software, SAP. With that, we're able to take that data and input it into ProModel, a discrete event simulator. Not only does it pictorially represent the actual operations of the warehouse, but it also gives the data that we want to collect as well. And so we want to verify and validate the model was actually representing the same data as that we collected within the actual warehouse. So with that, we were able to collect the warehouse utilization of the racks of historically 65%. And comparing that to the model, we were able to get a 64 and 63% rack utilization. So once we were able to verify and validate the model was accurately modeling the actual warehouse, then we were able to take the next step and move on to the solutions. And so the first solution that we wanted to look at was the specific rack utilization rate. That was the racks were not being utilized because the first order, first come, first serve, was actually randomly placing material between the floor and between the racks. And so we wanted to change the standard operating procedures to actually first come and fill the racks instead of the floor. We also want to look into radio frequency identification, or RFID. This is similar to GPS system locationing, whereas we can automatically track and count material coming into the warehouse and leaving. This would, in real time, track the material, and it would count how long that material has been sitting there. Instead of using SAP, the Enterprise Resource Planning software through Hydro Aluminum, we spoke to the material managers, and they actually want to reduce the amount of usage of SAP. And so instead of using SAP, we did choose to use RFID systems. Finally, we also wanted to implement re-layout of the facility so then we could reduce the amount of travel within the warehouse. And so now going back into the RFID system, we wanted to have an entire quote for Hydro Aluminum, so then they actually had everything set up to implement when we presented this to them. With a $6,000 hardware cost and a $27,000 software and implementation cost, it was overall $35,000, which may seem like a lot, but however, the $70,000 cost of audits for the inventory monthly is going to be an initial savings of $61,000 just by implementing the RFID system. Now, within the first year, we wanted to make sure that we have a quarterly audit of inventory counts, just to make sure that the RFID system is working properly to the actual warehouse. But after that first year, after verifying that system, we would be able to completely eliminate the labor. Going further into the financial analysis, we have a 5-year and 7-year cash flow with 35% tax and a 15% weighted average cost of capital, with a sum of a net present value of $123,000. Now that's over the 5 years. And the net present value is simply the summation of the cash flows of 5 years with the initial cost and the 5 years of the cost savings, with an internal rate of return of 101%, which is the discount factor at which the cost equals the 5-year cash flow positive influence. Now going back to the benefits of the RFID implementation, we're able to reduce the 2 specific standard operating procedures of looking for and finding the production order, as well as printing off the documents. We're able to automatically track and control inventory as it comes into the warehouse, and therefore be able to reduce the amount of confusion between warehouse and manufacturing, as now they would be able to produce less excess inventory because they know exactly how much they have. Now I'm going to hand it off to Zach, and he's going to talk to you about the dedicated storage system that we wanted to implement.
So as Joe mentioned earlier, in addition to the RFID system, we wanted to implement a system to allocate products to dedicated shelving based on the amount of flow outbound they had on a monthly basis, and incorporate this into a new layout. So the table on the left here shows the top 10 product or customers for Hydro Aluminum on a monthly output basis. As you can see, customer A has overwhelmingly more than the others at 46%. So obviously this customer should be located closest to the shipping and receiving dock because they have much more flow out that dock. So the methodology was to optimize this, to minimize the material handling, travel, and in order to do this, we had to talk to management first. And when we talked to management, they brought up a new point. They said, well, can you incorporate additional manufacturing space for us in your new layout? So what they had asked was that we incorporate new manufacturing space, which is shown in the yellow box here, adjacent to the existing manufacturing space. So we had to obviously incorporate this along with the new allocated storage system while minimizing material handling time. In order to do this, we used a software called VIP PlanOp, which is a facility layout optimization software. What we did was we input the shipping and receiving dock and the loading point of entry here, as well as the flow from each of the top 10 customers and the shelving requirements for those customers. As you can see, customer A, who had the highest flow outbound each month, is closest to the loading dock point of entry, which would be expected. From there, we took the existing shelves we had in the layout and allocated them to those customers based on the VIP PlanOp output. As you can see, customer A requires almost 13 shelves, while the last 3 customers can share 1 shelf because of their lack of flow out each month. Therefore, they're in the far corner away from the point of entry, while customer A is closest to the point of entry. So based on this output in a new manufacturing space, a new layout was developed. This new layout incorporated the new manufacturing space, incorporated the dedicated storage area, and also did not require any additional shelving to be purchased, so we could just move the existing shelves down closer to the point of entry to open up that manufacturing space. So based on that new layout, a new state simulation was created, and I will hand it over to Joe to talk to you about that simulation.
All right, so once we were able to verify and validate the current state simulation model, we knew that any changes that we made within that model would actually represent changes that we made within the actual warehouse. And so that's exactly what we did. We implemented the RFID system as well as the bin location storage for the top 10 customers. And so the operations are exactly the same, however, the layout has changed. And so specifically what we were looking for was with the implementation of the RFID system as well as the bin location storage, we wanted to increase the rack utilization rate from 65% to 85%. We're working on the current model. We have a distance travel of 6,500 feet per day, as well as a rack utilization of 65%. Moving on towards the new model that we laid out, we have a decreased travel of 4,300 feet per day, as well as a rack utilization of 85%. Now that came from the new standard operating procedures that we implemented. Finally, the total distance traveled annually was 103 miles, and that was the distance traveled because of the new layout. And finally, with the RFID system implementation, we're able to completely reduce the amount of audits annually, which was a $70,000 savings. Now I'm going to hand it off to Yars, and she's going to speak about the conclusions.
So initially we had set our objectives to reduce operating costs and to optimize space utilization. We identified the three main concerns that were taking place at the shipment department at Hydro Aluminum. One of them was the no standard operating procedures for storage of parts. There's a random pick and place storage system that has contributed to a lot of wasted time and wasted operations when it comes to trying to find parts along the shipment department. Also, the low rack utilization that highlights the inefficient space utilization in the shipment departments because of floor storage. That has also contributed to damaged part and increase in shipping delays. So we had developed three different solutions for these problems, which is one of them the implementation of the RFID system, which would allow to automatically keep on-time, full-time inventory history levels, as well as the redesign of the layout to allow for more manufacturing space, and the dedicated storage system that would optimize the warehouse productivity. Having said that, this is the end of our presentation. We really thank you for coming here, and we appreciate your attention. Do you have any questions or comments?